Johnson, and I'm actually not going to teach most of this workshop here. So Jaffe Walton is gonna teach most of this, yeah, so we gave this workshop a couple weeks ago in person, so we'll see how these do online too. And I'm going to start this off. We got your surveys, which is great, and thank you very much. It's quite a different set of people, so some people are going to have to, I guess, be a little patient as we work through some of the basics of certain things. But I wanted to talk about Rhino inside Revit. So Rhino inside Revit overall, for those that don't know, it's Rhino actually running inside of Revit's memory space, and so Revit and Rhino and Grasshopper all know about each other. We're working in each other's data structures, and working inside the API of each one. Yeah, and this getting started. So this is our website. One of the things I wanted to show early on here was our website, because as you leave this workshop, you're going to, need to go back and review things. And so getting started here explains overall, how to install Rhino inside Revit, and how Rhino inside Revit works and things like that. But if we go to the next page, guides page there, this one's, I noticed a lot of people in this workshop were pretty advanced at Rhino and Grasshopper, but said they didn't have a lot of Revit experience. And so on the left-hand side here, this page is split up into sections. And this first section is really, this top first section is really more about Revit in terms of, if you want to know how we interpret Revit's complicated. So you could interpret it in many different ways. But if you want to see how we break Revit down, this is the sections to do it. It talks about how Revit is broken apart and how Grasshopper kind of addresses that. And so if you're going back one of the things you're going to find with Rhino inside Revit is that it takes a good understanding of Rhino, good understanding of Grasshopper, and a fairly good understanding of Revit. And so kind of filling in your understanding of any one of those three is really the key to becoming effective with Rhino inside Revit. And so anyway, so this top section here is really about Revit, and the key document actually is the last one in here, Rhino to Revit, at the bottom of the list there. And that one is kind of the basis for how you're going to get information from Rhino to Revit. And it goes over the three main types. You get direct shapes, which have their place, but some people don't, or in some cases, that's not the appropriate way to go. It goes through how to get families, make loadable families, and get those in. And then it talks about how to make built-in native objects in there. And those are three different ways, why you might use them, where you can use them, and things like that. And so, and those are the main three types of families that exist. So anyway, so that's the document that you really want to kind of digest as you're trying to figure out Revit and Rhino. That's a good place to start. The next section here is about walls and grids, levels, floors, openings. It gets into design options, it gets into workspaces, it gets into all those things, schedules. That's really gets into the detail of how Grasshopper, the components Grasshopper has to deal with Revit. And so that works really well, mostly for people that know Revit really well and want to understand how Grasshopper can speak Revit. And so, it breaks down all the different kind of elements, all the different families, materials, how to work with them, all those things. So if you're, maybe need to understand a bit more about Grasshopper, but a lot about Revit, the rest of this list is, and as you go down through documentation and things like that, that's really where you want to be. But hopefully that gives you, kind of an area that you could go back and ask, kind of look. Then the next page here up top next to guides is called Discover. And this is a list of courses, a list of videos, a list of information in terms of videos in different places that you can go. And if you scroll down there, it starts with general. And then as you work down, it gets to more and more specific workflows. You're getting down to, running with schedules, or, things like, how to do adaptive components, or, where to go with how to create structural objects, things like that. So how to do curtain walls and things like that. So this is a great place to kind of see little workflows, especially if you find one that matches what you want to do. So are there any questions about that so far? And the last piece here is the forums right here. So the forums are this is where Jaffe, you're going to find Jaffe's up here every day. So that's his avatar there, and he's answering all the questions. So he's up here all the time. Okay. So those are kind of your 3 places to go back to after we get through this workshop. So and so the next piece of this, I think, well, where do you want to start, Jaffe? Do you want to start in here? Or do you want to start in Revit?
Oh, yeah, we'll just get going. There's a lot to cover.
Okay.
Especially in the beginning, this first hour is going to be a lot of real fundamental stuff, especially considering a lot of people are new to Revit. Some people are new to Grasshopper. I think all levels are gonna be able to get something from this workshop. So let's just get going. So initially, hopefully everybody's gone through, got the installation, use the getting started. When we start Revit, depending on the settings over here, either Rhino can start up automatically when we fire up Revit, or you could load on demand. So the initial place to go is this more, and then options. Here's some links to the forum, the guide. Right here, I have Rhino loading on startup. You can also isolate your UI settings, which is nice if you're used to working in Rhino, say in inches. Our Revit models are typically in feet or millimeters. So you'll want your Rhino settings to match your Revit settings. And we'll go into that a little bit more as we get going. This one is super critical. This is going to notify you on Rhino.inside.Revit updates. So we have a daily build that's released sometimes multiple times a day, where you're going to get the newest features, but you also might get a bug or two. So this is buyer beware. The release candidate, that's about a weekly release. That's usually pretty stable. It's going to have the new features, and nothing's going to hold you up. And then a monthly public release that's are stable. So choose which one works for you. And then finally, the script tab. You have a scripting location. You can add your scripts up to your Revit ribbon up top, right here.
That just allows you to put essentially Grasshopper scripts up there in the toolbar if you want single button usage of Grasshopper Player.
We recently had a request that Grasshopper doesn't load when Rhino loads. So if you have your options, start Rhino at startup, it's not necessarily going to load Grasshopper. We might add in a option for that, but a lot of firms have a lot of plugins, and that can be a little slow. So they made it on demand for your Grasshopper loading right here. And then just running through this real quick. This is going to fire up your Rhino. This is going to open up a viewport to get you going. You could toggle your preview for Grasshopper preview, get to your Python editor, also your preview in Revit, which I recommend turning off. It just kind of confuses things. You can disable your solver, and as well as a Grasshopper player. So let's get right into it. Actually, before we get into it, I want to kind of go over the options, because our space is changing a lot. We have a lot of options for Rhino and working from Rhino to Revit. Some of you may have heard about the new Autodesk connector. That's still in beta. I had it pulled up, but let's see if I can log in. Okay, yeah, so the Exchange, Autodesk is creating this Exchange connector, which is kind of like it's going to make everything interoperable between Autodesk products as well as other products. The Rhino plugin that they're developing is one of their first, because we're pretty easy to develop a plugin to, and it's been requested by a lot of people. The idea behind the Exchange is that your parameters and your geometry are going to be interchangeable. Currently, this is going to be pretty much at a direct shape level. And then so your Revit parameters are going to be user text. And then when you're exchanging your geometry back into Revit, it's going to be like direct shape. It'll be interesting. They're going to also have a Grasshopper version coming out, but this is essentially a beta, something to keep an eye on. But currently it's pretty low level as far as what your kind of geometry and customization. A couple other worthy mentions, and I apologize if I forgot anybody, because there is a lot of options. MKS Beam, which is has a light version for free. This essentially is no need for complex scripts or plugins. They want to keep things really simple. So it'll give you a Rhino interface, which you can organize by layer or attributes or whatever, and then quickly be able to connect to your Revit, to your Rhino. So if somebody that in your firm or yourself isn't an experienced Grasshopper user, and you want to deploy this to a lot of people that aren't going to be learning the softwares, this is an option. Like I said, they focus on simplicity, and that's really similar to Conveyor. Conveyor uses Rhino layers to manage, has some great workflows. I think you could try all these out. Another one is Speckle, which is going to be a little more higher level. I mean, I'm sure most of you are familiar with Speckle. And you can create native Revit geometry, as well as direct shapes, which is kind of the same thing with all of these. There is Grasshopper version availability, and this one's going to be a little more complicated. So the idea is that if you can't use Grasshopper so good, there are other options. And these are definitely worth keeping an eye on, giving a try. And like I said, I think there's a few more out there that we're checking out as well.
And we're seeing sometimes we're seeing kind of a joint strategy in firms. And so if you have a number of people that maybe don't use Rhino and Grasshopper a lot, but they know Revit, and they need to do, and they can do some translation using those one of those tools. And then you might have a more advanced set of people that can use Rhino inside Revit. And there you'd have a lot more granular control on how things go back and forth and what's created. And so you know, a number of firms kind of are looking at this joint strategy of deploying Rhino and Revit out there in production, kind of with it, you know, maybe with one of those plugins, and using Rhino inside Revit for some of the team. So that's a interesting strategy if you're trying to figure out how to use more Rhino and more Revit together in the process.
And the big difference is the Grasshopper. So being able to be fluent and be able to get your Rhino geometry in organized fashion into Grasshopper, and then your Grasshopper to Revit and back and forth is the big key here. The title of this workshop is like cross-platform data flow. So once you have control of your like we'll call small data, that we're not using like a large data set, but you'll see once we get going that being able to have everything synced up in a robust script, you can do a lot in whatever kind of workflow you're coming up with, either schematic design development, construction documents, maybe fabrication, there's all sorts of uses, but it's all going to depend on knowing Grasshopper. So that's where this workshop's really going to focus, especially in the beginning, on getting everybody kind of up to speed and a good workflow. This is going to use Elefront, which we're using the old Elefront, Elefront 4.3, super stable. Once again, Elefront's not the only thing out there. There's Human. There's several others. Actually, in Rhino 8 coming out, most of these features are native in Grasshopper 1. So these workflows are still evolving, but the principles we're going to learn today are going to carry through. These are the same workflows. Just a quick overview of our Rhino inside Revit interface. On the params tab, there's a bunch of containers. These are just generally holding containers, holding nodes. The bulk of our components, over 300 components, is here on the Revit tab, which is annotation. So our blue components are going to be things that create things in Revit. So you can build direct shapes. The green ones are query and getting information. The fuchsia are like document information. As you can see here, there's a mix, delete, and then orange is kind of just modifying. So we have our families, filters, hosts, various inputs, materials, models, object styles, parameters, sites, topography, type, view, and walls. So a thing to kind of remember is that we're limited by, I mean, the Revit API drives a lot of these things. So like when we add a wall by curve, that's going to be limited to like how you do it in Revit. So like if you're gonna add a wall in Revit, you're gonna pick 2 points, which is essentially adding a wall by curve. So that's why we only have add wall by curve or add wall by profile, because that's the 2 options in the UI. And then you got to organize your Rhino or Grasshopper data around that consideration. All right. one more thing before we get into the actual workflows is I just want to show a couple options and basic things you can do even if a person doesn't know Grasshopper or Revit. And this is the Revit sample project. It's in millimeters. My default Rhino inside Revit is in feet. So you'll see as soon as I open up Grasshopper, it should throw a warning that our units are going to be mismatching or didn't. Oh, there we go. So our model units are mismatching. It's in millimeters, Rhino's in feet. You could switch it on either side, but obviously the best way to do this is in Rhino. You could type in units in the command line, switch it to whatever the Revit units are. Now when our Grasshopper is unitless, so now it's a one-to-one, but one of the fundamental aspects is the graphical elements. And then when I'm searching for things on the Grasshopper canvas, you'll see I'm putting in the first 2 or 3 letters of the component. So if I'm looking for a graphical element, I'm going to type in GRAEL. That's going to filter that list for me. So I'm double clicking on the canvas, graphical element, bada boom. So this is just for people who really don't know Grasshopper. Maybe they've got a massive project with 10 linked files. They just want to work on a couple pieces without having to like import everything into Rhino. You can quickly set multiple graphical elements. So if I want a couple walls, there's a little finish button up at the top here. It's easy to forget. And now I have a preview of those. Another aspect is if I right click, I can set linked elements as well. Finish. So that puts a preview of just those elements. I just if I want to get these quickly in the Rhino, I can bake and bake. This is going to put in these objects as a block, but as you can see, we've quickly gotten items from Revit into Rhino without really knowing Grasshopper at all. So that's a really basic workflow. I understand there's a lot of fundamental things about Grasshopper that some of you may not know. Just to give the 1-minute synopsis of what Grasshopper is, in case anybody doesn't know. So if I make a box on our canvas, it creates a preview. And so this is a virtual object that doesn't exist until we can bake it. So while it's on the Grasshopper canvas, we can kind of chain together things that will allow us to build upon our existing geometry. So here I'm getting the faces, the edges. Let me put our full names. And if we wanted to add a box to every corner, if you grab here, and you could just kind of keep on going. And we could turn off the preview right here. At any time, this doesn't actually exist. But if we right click and bake, Pick a layer. It's going to throw this actual geometry and make it real. So that's the fundamental what Grasshopper does. Is there any questions here? Okay. Yeah, we'll get that. We'll get a list. Okay, let's start the workshop. It's gonna bring up even more questions. So
yeah, one of the things I want to talk about just real quick as we start here is that we're going to focus less on how to use all those components in Revit. And we're focusing a lot more today on how to move geometry in both geometry and data back and forth between Rhino and Revit. And so those of you that are advanced in Rhino, you know that Rhino is really good with geometry. And you're going to we're all going to find that Revit's got a little bit geometry and a whole lot of data. And so we find that the generic workflow that people kind of need to really understand is how do you move both geometry and data back and forth. And data might just be layers, or it might be colors or material names, or something simple like that, or it might be more sophisticated information like index information or some parameter number. And so you're going to see today that we'll concentrate a lot on here's a geometry flow, here's data flow, and then we bring them together. And then we'll get more and more sophisticated as we move forward. But just to know, that's kind of you'll see that a lot of these examples are going to be quite simple, but we're actually just really trying to get across how to do both geometry and data at the same time.
And it will get more complex.
Oh yeah.
And knowing that there's some really new Grasshopper users here, I sent that link to this page, which has everything, like all the steps that we're going to go through, as well as the Grasshopper file. So if you get a little stuck or you find yourself falling behind, feel free to just open up the Grasshopper file, and then that way you can kind of skip forward without getting too bogged down. And then it's also a resource that you can kind of go back to later. So this initial step, Grasshopper to Rhino. We're gonna just throw our, we're just gonna start out nice and simple. So we're gonna make a rectangle. So I'm looking for this one right here. And I'll zoom in. If anybody is having problems seeing things, let me know. And then, so I'm double clicking on the canvas. I can get a slider just by typing in a number. And we're going to control the size of our rectangle. The next one is going to be a box rectangle. So this is going to take our rectangle and take a height to control it. So we'll do another number slider by typing in. There we go. So right here, you can see the names of the components here. This is the sunglasses plugin that I included in the material. Super helpful. And if anytime you get a little bit behind, you can look at the names here and follow along. Another aspect is my middle mouse button, and I could disable our preview and do a custom preview. So I'm gonna CUPR, add our geometry to our custom preview and generate a swatch, color swatch. Make things a little different. All right. So now we're going to kind of get into the elephants. This is still just virtual Grasshopper geometry, Elefront, broken into several categories: reference, filter, attributes, baking. So we're going to start off with baking. So we're going to bake objects. You could search for that by BAOB. If you have the newer Elefront, make sure you're not mixing up your components. That can get ugly quick. So in this case, we're going to feed our geometry. Then we're also going to define our attributes. Define at right here. And we're going to add in a little additional information for the bake name. Rhino box. So right there, to get a panel, I could either type in panel, or I could do a double slash and then start typing, or a quotation and start typing. These are single line panels that if you have multiple items, you would need to right click and do a multi-line data. This is just going to be a single item right here. So we're going to put this as our bake name. We're also going to use this as our layer. So that's defining the layer. And we're going to put a user key and a user value. I'll explain what those are shortly. So we're going to call that one my key. And that's looking for a value right here. Give everybody a second to catch up. I'm going to go ahead and activate, which is going to bake our geometry here. So what that does when we bake, I'm going to pull up my full Rhino here and get rid of this. Go here. Since we're working in 3 different programs at the same time, it can get a little crowded, but we'll do the best we can. So now that this geometry is in Rhino, we can go to this blue attribute user text, and we'll see that my key, my value is attached as our user key pair value. So the other aspect of this is the bake name. So when we change our object, you can see our Rhino is not automatically changing, but if we hit activate or had a button on our bake component, so if we do a button right here, the bake name is going to replace any existing Rhino geometry with our new Rhino geometry. This is just it's looking for a change, so we can actually feed in our height difference. That one right here. So now when we're changing here, our Rhino is changing. So I'm going to give everybody just a second to catch up. And then we're going to take this into Revit. Right. So our next step is to get this into Revit with those same attributes. So we're going to go back to our Revit material. We're going to convert material. So this is looking for a shader. So I can create that material. So when our Rhino inside Revit component
Jeffy,
turns black.
Jeffy, can I interrupt you?
Yeah, anytime.
I mean, I guess I just did, but um, Timothy's asking about the object attributes that you have over, I believe, over in Rhino. Can you just show them where to find those? These are actually, yeah. So they're the key value pairs. So you're under object properties there, and then you're out on, yeah, you're out on the key value pair. Is that what you're asking, Timothy?
And Elefront actually has their own version of that here. I didn't include that. That has a couple extra. You can match attributes, export, delete. For our purposes, we're just using the native Rhino. Like I said, in version 8, Rhino Grasshopper 1, this is all going to be, most of this is going to be native. So.
By the way, how many people have gotten this far in the workshop? Or who do people have questions here on how to get even as far as they are here? Okay, so see here. So one of the things is to make sure you're zoomed in enough.
Oh, yeah.
Yeah, I know. I keep doing that. So, and so how's everybody else? I think everybody can speak on this too if you want to do that. We're doing chat, by the way, so chat's going on, but also if anybody's got any questions.
Let's go ahead and
okay.
Yeah, let's fire through this next part. And once we get through these about first 3 steps, hopefully we'll take these first 3 pretty slow, and then we'll start moving a little faster. So what we're going to do, so we made our material. So one thing we can do, now that we've baked an object with a Elefront bake name, we can reference by bake name. So now we're gonna, So now we're gonna reference our Rhino geometry back into, there it is, back into Grasshopper. It's looking for the same bake name. I'm tapping Alt to copy something in Grasshopper. And so I can reference by bake name here and get this geometry once again. I'm also going to right click on this and disable the auto update reference objects. This is going to keep it so when we actually change something, so if I put a volume into here, when we change something on our slider right here, you can see it's referencing and changing here on the fly because we disabled auto update reference objects, which I would think that would be enabled, but yeah, that's what it's named. All right, so now we've re-referenced this geometry. We're going to add a geometry direct shape. And we're going to add a couple other components here just because as soon as we drag this geometry here, this is going to create the object in Revit. So let's get everything kind of set up. So we're going to add our geometry. We're going to add our material here. Yeah, let's go ahead and drag it. Boink. So now we have a massive box because they're working in feet. And I can get back to my Revit dialog way over here. Nope. Scoot this up. Move my zoom. Get the shaded. You can see our material is active as well. The next step is we want to get our key pair values as parameters to our direct shape. So to add that, we're going to need an element parameter component. And we're going to need a parameter. So we're going to define that with define parameter. At any time you want to see where these are in the Grasshopper canvas, you can hit Control Alt and gives us the info. It's going to show you where that component is coming from. So if we want to quickly switch back to the elephant, we get the info here. It's going to say, hey, that's coming from the reference tab. Define parameter coming from the parameter tab. So we're defining a parameter. We're going to keep it the same name. So we're going to use the my key. Whoops. And then, so that creates a definition, but we're going to have to add parameter to our document. So this is just defining a text parameter for various categories and then assigning it. So we can either grab our slider to feed as a value. Yeah, I think we'll do that first. We're just going to add our slider as that value. That turned black, so now that made the change in the Revit document. I'm going to scoot everything around so we can try to see stuff. So now when I select my direct shape in Revit, we have my key. If we go back here and make our changes, reselect here, you'll see the my key is changing as well. Take a moment to organize.
Let's stop here.
Yep.
Get everybody caught up. Yeah. So a couple things to remember here. Zoom back out a little bit, Jeff, if you could. So this first part of this definition here, which is this part right over here that Jeffy's showing. And by the way, these are up on the Google Drive, and this one's called, I think we're at 1.2 now. Is that correct? Yep. So the 1.2 Rhino Baked to Direct Shapes one is where we currently are. But this first part here, these first section here is, you can see this kind of pattern you're going to see over and over again. You see we're creating a box along the top here, and then we're pushing that into a bake component. And so what we're really doing here at the start is we're just making a box, and we're actually going to bake it into Rhino. Okay, we haven't started to deal with Revit here yet. And then we create attributes. We create text attributes, user keys here, and that goes into the bake component too. So that's this whole first part here, right here up to where that Jeffy, your cursor, put your cursor on the bake component there. So everything before this is actually simply about making geometry and text and bake them into Rhino. It actually doesn't have anything to do with Revit, but it is the workflow of getting information into Rhino that's both text or both data and geometry. Now, if Jeffy pans over a little bit to the second section here, so the second section, we're actually doing something similar, but we're going to go into we're going to take that box that we created, right? And we're going to create a direct shape, which is a certain type of Revit element. And then we're going to take the text information, which is data, and we're going to add it as a parameter. So in Revit, we have either a direct shape and a and text, or we'll have a family in text. Okay, so this you'll see this. So you can kind of use, you can actually use this definition, this part of the definition right in the middle here by itself, if you already had geometry in Rhino and needed to move it to Revit. So this little section here in the middle is the Rhino to Revit piece. Now, some people were having trouble kind of getting things opened up a little bit. Did everybody get that figured out? One of the things that wasn't clear, I guess, is if you open Rhino by itself, just Rhino by itself, and then you open Grasshopper, you will not get this Revit toolbar in Grasshopper. You have to open Rhino from inside Revit, and then you can open Grasshopper from there. And then Grasshopper knows it's inside Rhino, which understands that it's inside Revit, and that's when it actually displays this toolbar, right? Because these components here on the Revit toolbar require that Revit's running, because they, of course, use the Revit API. So does that help? So, and I believe all parameters that you create are always shared parameters in Revit. So the answer to that question of, is it a shared or project? It's a shared parameter. You can make project parameters, but that's a different component. So, okay, but it is a shared parameter. Okay. Other questions people have? So what I would do is, if you're finding yourself falling behind in any time in this workshop, just open the next file in the workshop notes, and you'll get the definition already done, and you can kind of play with it. Okay, so we're gonna, can we post that Notion page, Jaffe, on the chat?
Yep, I sent it in a link.
Right, so let's throw it on chat too. And so then you can see the names, how the definitions are put together. You can see that Jaffe's highlighted the stuff we've covered previously, and then you can open those, and that way you can jump forward to the to where Jaffe's headed, essentially. That'll help a lot to kind of, you can mess around with them and play with them and adjust them as you see fit, as opposed to having to worry about dragging all of these out all the time. Okay.
And we'll get through this one next little section, and we'll take a short break, and then give everybody a chance to gather their thoughts a little bit, and then we'll pick it up again in a few. So now that we've gotten our direct shape into the Revit, assign a parameter, let's take it back in the Rhino. So to get information from the element, from Revit, you can use element geometry component. So when I do that, and then so that actually gets a more Rhino and Grasshopper type geometry. At the element level, it's still a Revit direct shape it's referencing. Now, coming out of here is a closed BREP. So that's what Rhino is going to understand. Then for this purpose, we're going to move it. So we're going to place a move component. Let me zoom in here for you guys to follow along. We're going to move it in the Z value. So I just typed a Z. So it's looking for a vector. And we're going to move it by our value from our parameter. So we're basically just going to put this on top. Like I said, this isn't any sort of real world scenario. This is strictly showing kind of the workflow of the data and geometry from Rhino to Grasshopper to Revit, from Revit to Grasshopper to Rhino. So we can do custom preview here once again. Boom, boom, boom. Watch. here, turn off the preview there. I have some extra previews, but and then so right now this is just a preview. So once again, we're gonna have to bake our objects. Back in the Rhino with the baked objects from Elefront. We're going to define attributes. Once again, we're going to use the same name of my key. So it's giving a warning. It's, hey, you need to have equal number of keys and values. So we're just going to give it our value. And we're going to give this a bake name of Revit box top. And once again, when we change our size, we want it to bake. Oops. So that was getting out of, oh, I got the wrong one. I wanted the value. So when the value changes, these little pills here just for help you organize and straighten out your wires a little bit. If you double click on the wire, you can get back and forth. So now we have our integer going in here, which bakes it as true. And if we start changing our slider value, we have a full loop of geometry. I'll leave it here for a sec. A full loop of creating a box in Grasshopper, taking it with attributes in the Rhino, referencing the geometry from Rhino, adding it to our Revit file, taking the attributes from the Rhino, applying to the Revit, taking the Revit, and bringing it back into Rhino. So that's the that gets us through 1.3. So that's the easy part, because that's pretty much handling one piece of geometry, one piece of data.
We can take some questions. We can take some questions now so people can get oriented to what's going on.
I was baking this geometry, not the move geometry. There we go. Yeah, so let's take a short break. And if anybody has any questions, we can answer a few of those now. So Elefront isn't loading for some reason. That's going to be a problem. So when you place your Elefront into your special folders, one thing that you'll want to do is right click, go to the properties, and go to the general tab and unblock. So it may be blocked. That goes for loading any Grasshopper plugin.
I have a question just about the overall logic of this.
Yeah.
So is it that each time you want something, or you want whatever geometry you're working on in Grasshopper to populate in Revit, we have to bake it?
Populate in Revit, yeah, it's going to either depending on the geometry, it's gonna be one of the cyan components. So you're gonna be adding it to the Revit document. And like I said, as soon as I add a geometry, that Revit document is triggering. So that's where we have an add that can be a little dangerous. Add direct shape, and we don't want it. We can disable a component so it doesn't automatically bake.
So it's the direct shape that's the thing that's communicating or like populating Revit as opposed to the bake.
Right.
Okay.
Right. So anytime it gets it is a little different than it is in Rhino. So you can preview Rhino geometry in Revit, right? So it'll preview over there. That's fine. But that's Rhino geometry over in Revit. Okay. One of the things you can't do in Revit is you can't preview Revit geometry in Revit without baking it. So anytime there's a Revit object created, even if you're previewing it in Rhino, it has to be baked in Revit. So direct shape's a hard one to imagine, kind of think about, but think about a wall. So when you create a wall in Revit, you have to have 2 points, right? And there's a line between them. But in order to visualize that wall, it has to be created in Revit to even visualize it. So there is no such thing as an element created in Revit that doesn't exist, that's not already baked, if that makes sense.
Got it. So the purpose of the bake objects is to start the communication so that I can reference something in Revit. Is that what that's for?
Oh,
This one's always into Rhino.
Okay.
And any of these black ones, like whether it's a direct shape, add direct shape, or add new family or something like that, those are the ones that are working in Revit.
Okay.
So and you can see here too that it turned black. So when any of these components turn black, it means they made a change to the Revit database. Right. So you actually made a change. It's actually good if they're black. But no, yeah, anytime they've gone black, they've made a change over there. But there is no such thing. There's, like, going back to that same concept, there's no such thing as preview geometry in Revit of Revit objects that aren't baked, because it's always baking. Yeah. It also makes it slow. It also makes it slow, of course.
Right.
And so
that was my experience using Rhino inside when I had to populate like 1,000 blocks.
Right. And so that's why we do a lot of like we were showing where we do a lot of, like, you disable those components. So you disable the Revit components as a strategy a lot of people use. Some people actually turn the solver off and then do all their changes and then do it. And then there also is a timer. So there's a timer, a trigger that you can use, and you can wire it up to multiple Revit objects. Is it timer? Is it trigger? Right. And so you can wire that, you can actually drag that onto the Revit components. And what that'll do is for instance, you can set it up so that, so I could wire that to multiple objects. You can see that it goes into the object, and you can actually disable all the Revit components, go through your Rhino fast. And then you can, trigger Revit with the trigger there, and they'll all update what's in Revit. Does that help?
Got it. Yes. So the purpose of the original bake, where we're doing the reference by bake name, etc., is that's my main question. Like, what's the point of baking in the beginning if the direct shape is what's referencing in Revit?
He's baking it in Rhino. That's actually starting to bake information into Rhino. Right.
Yes, but like, is the point of that so that the direct shape can pick it up based on the geometry and name?
Yeah. So imagine, right? You could skip any one of these, right? So you could not bake into Rhino, of course, and you could just go to direct shape and name and forget all this baking into Rhino. But we're finding there's workflows where there's a lot of times people want to bring geometry over from Revit, and they want to bake the parameters into the Revit object. That makes sense?
Okay. Yeah, that makes sense. That's
right.
That's an application that I'm trying to do right now.
Yeah. And so using Elephant to kind of manage the parameters, as it were, on the Revit side and then using, of course, Revit's database on its side. That's how those two interact. That's
Okay.
what this definition is all about.
That's really helpful. That was what my main question is about.
Great.
Thank you.
And then there's a question here, how does the box get located? With the direct shape component, it's going to be based on where it is in the Rhino space. These, it's not like a family where you're going to tell it which place to go. The direct shapes have you could create a direct shape type that can be placed, but it's still just kind of a quasi type. So then you can add a direct shape type by location. But in general, the direct shapes are going to come in wherever whatever space they are in Rhino. So the next one we're going to go into is actually going to be creating a Rhino block and then a Revit family from the block that can be placed at different locations. So the direct shape's different. That's your model in place component essentially. And that's going to go in place. So there's no location information unless you create a direct shape type, which is not really a family. It's not an editable element. It's still just a direct shape.
Yeah, so direct shapes, just wherever it is in Rhino, it's in Revit. And so that's pretty straightforward. It's only when you get to families and instances of families do you have to worry about insertion point. But that's, you know, you can imagine, for those of you that don't know Revit, you can imagine that a family is kind of like a block. I mean, it's got the same kind of structure in that it's got an insertion point. It sits at 0, 0. But direct shapes are just more like just throwing geometry back and forth.
No, Colin, that's yeah, that's a default parameter in Revit. So one of the direct shape categories, you could assign like different categories, and whatever categories those are might add a little bit of different parameters based on that category, because that's when you create those parameters, they're per category. So anything with that category is going to get that instance parameter. So yeah, I don't know why it has the rebar cover, but choosing a different category will get you different results.
And it's important to note that you know, families are a much more sophisticated way of classifying things in Revit, and if you can, especially if that model is going to be used for any length of time, you almost always want to use families above direct shapes, even though direct shapes are super easy and super, you know, they seem super easy to put together. From a BIM manager's perspective, direct shapes are a nightmare. So, and a good example, Colin, is what you're putting up here, is that they don't have as many defaults. They don't have as good at templates. They aren't as much under control. So moving to, you know, kind of that next level of sophistication and using correctly classified families is really the kind of where you might want to head with what you're doing in terms of putting objects over there. Direct shapes, I would say, are used mostly for like competitions, for a quick design review, for something that isn't going to really last for a long time. Where families and using loadable families is usually a much more effective way to be able to fill out the BIM database, as it were.
Okay, so we're going to do this next part, which is going to be to create a Rhino block in Grasshopper using the elephant components, and then we're going to take that into a family and place a family.
This is This is the number one request we get for Rhino inside Revit. Can I make my blocks families?
Yeah. And this is still working on a flat data structure, trying to keep things simple so you can kind of understand the workflow before we start getting into more difficult branched scenarios. So we'll head right into this one now if everybody's ready.
I have a question about the units because probably I wasn't able to explain it properly. Is there a way that when you launch Rhino from Revit, obviously, Rhino automatically detects the units that you are using in Revit?
It detects them, but it doesn't change them.
It actually does that. It actually does that anyway. So you know, when you bring it up and it says Rhino's in inches and Revit's in feet, it's actually going to do the conversion for you, even though Rhino's in. It's just telling you that they're different, but it doesn't necessarily mean that it won't translate. So if you translate a chart, it'll work that way. Now, if you go, you know, Grasshopper, you always have to remember that Grasshopper itself is actually not in units. So if you were to create a box in Grasshopper, are you creating in feet or inches? You're actually creating in inches because Rhino's in inches, but we'll translate it. Once you go to direct shapes or once you go to families, we actually translate the size for you between those two, even though they're in two different things. Now, if you want your Rhino to always start in the units that you always have Revit running in, then what you would do is you would set your default template in Rhino to be however many, whatever those units are, right? So when you say new, you'd set default template to feet, let's say. And then Rhino's always going to start in feet, which your Revit always starts in, let's say, and then off you go.
Yeah, I was asking more because usually it happens that sometimes, you usually work in the same kind of units, but all of a sudden you open a different file that is working in a different kind of units, and it's easy, you have to change it. But when you are deploying those scripts to other people at the office, sometimes they kind of skip that part. And that leads to more problems. So I was wondering if there was a way.
If you're I mean, if you're generating geometry in Grasshopper, then you have to be kind of aware of what the units are. But if you're doing it in Rhino, then you do. And the other thing to remember is that the defaults in Rhino inside Revit for Rhino can be different than your defaults when you're running Revit outside of Rhino. Even on the same computer, right? So,
Okay, thanks.
Yep.
So here we are going back into the work part. I just kind of deleted the objects that you don't have to start a new file or anything, but I started a new Grasshopper file. You can either copy and paste your rectangle, or just create a new rectangle and a new box rectangle, and you can make it a different color if you'd like. Turn off the preview. So now we're getting into the 2.1 Rhino baked to box. So this will actually go pretty quick since we've covered most of it. So now we're going to define block. Define block, which is an elephant component right here in the block. And this will take geometry. So we're going to add our box here, and we're going to want to define attributes. And so the big difference here is we're defining the internal attributes of the block. So the block will be an instance, and it'll have geometry, and then the internal geometry can have its own user attributes. In this case, we're just going to assign a layer. Go ahead, Scott.
Yes, there's somebody that needs to be allowed in, I think, admitted. Top here. Callum got out and then got back in and on the different.
Oh, sure. Okay.
Did you find him?
Yep.
Oh, yeah, cool.
So now we're defining the layer that this geometry is going to be baked into. And then from here, now we're going to bake our objects because it's not an actual Rhino block until we get to actually bake it. And we can define attributes that go onto the block instance. So one thing we want to do here is come up with a name for our block. So let's see. Let's make a height adjustment. And we're going to use a format component. So our coders are probably familiar with this. This is where you could feed in as many inputs as you want, and then you could you can create a format by our squiggly brackets. So I'm going to name this block underbar squiggly brackets 0 squiggly bracket. That. And what that generates for us is block 4. One great thing about the format component is being able to pad zeros. So I'm gonna put a semicolon with a couple of zeros. I can pad by numbers, so I can get a little bit better sorting. So the format component is really good one. That's part of the text in Rhino. So that's going to be our block name. And I think we'll also use that as our, let's see. Yeah, we can use that as the bake name. And once again, we're going to use the slider. I'll zoom in here so everybody can catch up. A little bit. I'm going to scoot this over. So now we have our block. Go to our object properties. It's block 4. The oh, we didn't put a layer. So once again, we can put some key values. Block. Let's actually use that for the bake name. Layer. Key. So it's the same thing we did in the first exercise. So once again, there I added a better bake name. I can delete this. A Rhino block, added the key, added our slider value as our key value. So now, just like we did before, but now we have a block. That hopefully went a little quicker. Oops. Oh, that's called. Everybody caught up? Okay, let's turn this into a family. So once again, we're going to reference by big name. This is getting our Rhino object. We're going to deconstruct block. So it's going to get the geometry, the plane, and the name of the block. And we're going to make a family. So to add a family, it's going to be called new component family. Actually, new component family. There we go. So this is asking for a template. Whether you want to override your block, its name, category, and geometry. I'm going to lock this till we get everything set. So we need a path. So the quickest way to get a path is if you're in a Windows Explorer and you hit Shift and right click, you can get copy as path. When you normally right click on a file, it doesn't give you that option. You might be able to set that to permanently do it, but if you shift right click, you can copy as path. So knowing that, I'm going to go into a file, new, family, which will take me to whatever Revit version you're working in. I can go here, copy as path, and then cancel out of creating that location. And it's going to give us our path with quotes. So you have to undo the quotes. So now that we have our template, we have our name, we have our geometry, we can create our family. Give you a second to catch up. All right, now we can add our family by location. Add components by location. So it's looking for location. We're gonna construct a point, C-O-N-P-O. Come on. Construct point. We're just gonna put it somewhere. So we have a location. It's asking for a type. So currently this is a Revit family, so we can get our family types. And then you could see it made our preview and added our family. And then once again, we can get our element parameter component. And this time we're gonna get our value directly off the referenced geometry. So in Elefront, in the attributes, you can get user value. You can get user value from the geometry, and Elefront has this nice, if there are these little brackets shown when you don't have the full names displayed, you could put in a value list and get your auto populates the key pair values. So the my key is a parameter. If you still have that same Revit file that we created the parameter in before, it's going to be fine. And we could feed in that value. So now we select our family and key value of 4. So if you wanted to place a bunch of these, you could, let's see, a series. You don't have to do this part, I'm just showing it. But every 5 feet. Oh, so that placed one every 5 feet, for instance. Gonna make this bigger, let everybody catch up.
So one of the things I want to be clear on here is, as we're, I guess, as people are looking at this, is that everything in Revit, everything useful in Revit is in a family. Is the best way to put it. BIM managers will tell you that everything's a family. And that's like saying in Rhino, that would be like saying everything is a block. Like to put anything useful in Rhino would have to be a block. That's essentially the same parallel, but in Revit. So families have a certain hierarchy. So you have families, which is like the block definition, right? So you always create a family, and then family have types, and so like certain families can have multiple types, although in Rhino, or the kind that Rhino can create, is only going to have one type. And then you have an instance. And so the instance of that family is what's actually inserted, like a block insertion. So you can have multiple instances, of course, of the same family. And so one of the things for those of you that are trying to get used to Revit is always think family type instance. Family type instance, family type instance. That's, you got to have all 3. If you don't have all 3, it doesn't exist in you can't see it in Revit. You know, you can make a new family, which will be held in the database, but it won't actually be inserted in the file. So always think family type instance. So yeah, so if you go to our definition of it's actually at the up there a bit, might be even under overview. So
Well, we never did talk about tolerances, but
yeah, I haven't done that yet. So there's element IDs. It's in there. Placing instances of types at the very bottom. But yeah, so you always, so just something to think about is it's always family type instance is the hierarchy in Revit. And it just adds one more level of complexity to Revit, but you'll find it super useful. And different families belong to different categories, right? So there's multiple categories in Revit, and you can imagine categories are like layers. So in Revit, categories are like layers. Those are like the category of walls, or the category of doors, the category of windows, of HVAC equipment, of structural framework, whatever. Those are different categories. The thing with Revit that's different is categories are hard coded. So you can't create new mainline categories in Revit. You can only use the hard coded ones. Now you can create subcategories, right? Those would be like sub layers in Rhino, but you can't create you only can use the hard coded categories in Revit that are at the very top level to begin with. All right. So just to kind of think about as those trying to learn Revit, is categories are like layers. Hope that's helpful at some point for you guys.
Yeah, and a lot of this, yeah, Revit is very huge, it's very complex, but at the essence of it, you're going to be working with these same kind of properties, parameters, data, and so far we've been pretty simple. We've just been using one value. So now we're going to start getting a little more complicated. Now that I hope you have a good understanding of like the single data workflow, how you can, our first one where we got to Rhino to Grasshopper to Revit back again, how that works with a block and a family. So we're going to start a new document. And we're going to go into more branching. So we're going to do the same thing. So we're going to do a rectangle with a box rectangle. Same thing, but now we're gonna make these a little more dynamic. So for our size, you'll see the size is actually getting a domain. So it's -1 foot to 1 foot the other direction, or a unit. So we can construct domain. We just want to 0 to 6. So now we're controlling that size a little differently. Here, we're going to put height. Now this time, for a plane, we're going to construct our point. This could be a plane as well. And then we're going to use a series. So the series is going to give us a list of numbers. For this, we're going to step it by our size, and we're also going to do the count on size. So now we've created a list, a single list. So our right up here is telling us our branch ID is 0, and we have six items starting with 0 of the list. So it's a little more dynamic, and we're creating multiple boxes. So what happens when we go and bake objects, we're going to have to start managing our branch data and attributes. So now we're going to define our attributes. So currently we have 6 items, but actually we want those each separately. So we're gonna graft. So there's a graft component. So this is going to turn our single list of now 7 items into 7 lists of 1 item. A good way to see this is our RAM viewer. So if you look at the tree here versus single list, 7 items. And to do that, we can also right click on our input and graft. So that's going to give us the same graph structure as our graph component. Now for attributes, we're going to need, so if we just fed in our list of all these numbers right here, it's only going to give us 1 attribute to our 7 different items. So if we had unique values here, that it's we need to make actually 7 different attributes to match up with our 7 pieces of geometry. So to do that, we're going to make another series. We're going to use this as the count. This time we're going to start with a 1, because we're actually going to use this as a number right here. Let's go ahead and format that again. Zoom in, remove this one just because we don't need it. Not there. And if anybody's still struggling with a Grasshopper, I'm using Control to remove a branch. I can just add a branch. Because there's some basic things. So here we're going to do that same formatting we did before with curly brackets. 0, 0, 0. Doesn't like that space there. So we're going to make sure we're not putting anything extra. So now we have our seven numbers. We're going to graph those as our user value. And we're just going to call this number. Put a bake name. All right. Give everybody a minute. Once again, if we change something, we can go ahead and bake it. So the big key here is we have 7 lists with 7 individual attributes. That'll change as we go along. So that's number 5.
Could you,
1, 2, 3. Yes.
yeah, could you go slide the grass? Couldn't you have graphed when you go to box and you have the list and you're going
This one?
Yeah, but you're going into activate. No, you have that one, the one you had before. Right?
Okay.
Go to the bake objects component.
Okay.
At the very top in geometry, you're simplifying, but you're grafting, right?
Yep. And the simplifying.
Couldn't you just graft coming out of that? And
coming out of here?
Yeah.
Yeah. Yeah. So I could graft here.
And the only reason I say that is that the key, this is the part he's shooting for, but I wanted to be really clear in this, was that you want to make sure that all your data and your geometry are all grafted in a tree, all matched data wise. Anyway, that visually makes it clear what you just did there. So,
and then once again, we're going to reference by bake name here. So even though we had our grafted list, when we re-reference this geometry from, let me turn up all the previews. When we re-reference this geometry, it came out as a flat list once again, which is kind of important. So we might have had these grafted for a reason by maybe by floor or by type or something like that. the reference by bake name has a maintained tree structure. So now it's going to rebuild our tree structure from our essentially dumb geometry. It'll bring it back in an organized fashion with a maintained tree structure.
And an example where this type of thing might become important. Imagine this was a facade, right? So this is a row. We're headed that direction, but think about this as a facade of panels, you know, that you have in Rhino, and then you're going to have to figure out how to get these facade of panels into Revit. And so that's you can imagine where now we just have the facade in Rhino itself. So this is a good example of something that you're going to be able to do that kind of workflow with.
All right.
All right, so there's a question there, how grafting is different than simplifying.
So
Grafting, yeah, go ahead.
the simplifying, so right here you see when we have our branches, there's a bunch of extra zeros. I got zeros and there's four trees, but when I simplify, it's gonna, if those values are the same, when I simplify, that tree structure is gonna be just 0, 0, 1, 2, 3. It doesn't have all those extra zeros. When this bakes, it actually does a simplify for you. So even if we didn't simplify here, it's a good question. It's still going to come out. It's not going to have all those unsimplified geometry. Where that gets really critical is if you're matching up different incoming branches. You're going to want to simplify and make sure that they have the same branches. Trees can be a challenge for sure. It's really nice to have this param viewer. You can also display it as a tree here, where you can visualize, hey, I got one branch. Versus a grafted branch or a grafted list. Does that help? Because it's going to get more complicated here shortly.
You guys hear me?
Yes.
Yeah, that definitely helps. I think it's the visual actually is really helpful just to see where we are with the data structure.
Thank you.
Could you do one more thing? If
Yeah.
you could explain what grafting what it means in general.
Well, it's here we have a single tree with 7 branches. What's the best way to describe that? And then so in grafting,
yeah, it goes. Yeah, I mean, let's go. Let's just graft that point. So give me another on that panel there. Yeah, just give me another panel off there, but graph the tree. Yeah, and then give me a different panel. Okay, so let's look at the panel to the right. So the panel to the right has 3 points in it, right? A point is made up of 3 numbers, right? X, Y, and Z. Okay, and so, but that's a list. It's just a single list. The stuff to the right is a single list of points, right? 0 through 6. Okay, and then the panel to the left there, that's actually when it's grafted. So you can imagine what's happened there is we actually have 7 lists. So 7 separate lists of just 1 point each. All right. So, and a lot of times lists are simply lists in Grasshopper, and graphs or tree branches are actually, like, let's say, separate objects. So an example where you might use this in Rhino inside Revit. Let's say we're making a family and and if we put in a list of 20 objects, we're going to get one family of 20 objects. But if we want 20 separate families of one object each, we're going to graft that list. And so now we're going to have a tree, like the list on the left here, or the tree on the left in that panel set. And that is what that's going to generate is 20 families of one object each. So do you understand see how the difference is that we're using, you can think of a list as just a single list of objects, where a tree is each branch is a whole new object or a whole new list. That's how we.
So the structure of the way that the points are fed, I guess either as a list or I guess in this set of situations, it's a bunch of points. The structure is a little bit different. Am I kind of articulating that correctly?
The structure is different, but understanding why you might use a tree over a list is a lot of times we use the tree branches as specifying separate elements, separate entities, where you can think of a list as actually one object, which happens to be a list of things. And so,
okay.
Right. So like imagine on the left-hand panel, you could have lists inside, so it says, in brackets, it says 0, 1, 2, 3, 4, 5, 6, right? That's each the branch number. You can imagine each of the bright yellow areas could have multiple points in each one, right? Each one could be a list. So you have the hierarchy in Rhino is the simplest is a single object. The next level up is a list, right? And then the next level up is a tree, and each branch of the tree could be a list. So
here's a good illustration. So I took our points, right? So we have our grafted points, seven different individual lists. And I have one point out here in space. And if I take this list and this point, it's gonna take the first item in the list, which is there's only one item, and go with the first item in this list, which is there's only one, and then it's going to draw this line in between them. If I move this and I had a matching list of 7 items to this 7 items, and I do here, now it's gonna draw these together. If for some reason I accidentally flatten this, now it's going to draw a line for every one of those points to every one of the other points and create a whole lot of points.
I see. Okay. That illustrates it. Yeah, much better. Thank you.
Yeah. Yeah. So that's where that's where, I don't know, people with a lot of Grasshopper experience, if they accidentally drag their flat list of 10,000 objects into another 1,000, like into another one, all of a sudden they have a million things going like this, and it'll overwhelm. So this is being aware of if you're dragging a flat list into a grafted combination, in this case, is kind of a big deal. So you definitely want to. What we're doing in this exercise is matching our lists. So we have a list of geometry and a list of attributes that are going to match, just like these. We don't want our attributes like that. We could do attributes like this where they're all getting a single attribute. But the goal is nice lines like that.
That clears it up for me. Thank you so much.
Awesome. Fun. Yeah. That's why we're kind of taking the time and doing this. A lot of people don't know about some of these elephant features. Yeah, some people don't know about the Revit or getting this communication, but it all comes down to working with branch data. That's where if you're using some of those other Rhino and Revit interoperability, such as conveyor or speckle, it kind of takes this aspect out to some extent. So this is kind of why we're taking the time to go through this a little extra. And that's what we're going to kick it up a few more branches now. Yep. Cool. All right. So now we're going to move on to our next step, and this is 3.2. We're taking these kind of slow because, yeah, like we just went through, it takes a second to just kind of wrap your head around what's going on in some of these branching items. But once you get it, it's still,
Yeah, once you beat your head against the wall long enough and it sinks in, and then all of a sudden it's like, oh, that's how it works. Just everybody needs to be clear that trees are they take a while to learn. You just got to keep working with them and fighting with them, and then they start making sense. And Nico did on the chat put a nice guide up there that is helpful to understand what.
And there's a lot of great guides. Andrew Human put together one years ago that's fantastic. Like I said, some people like really can just kind of start going in Grasshopper pretty quick. But some people, once they get into the tree parts, kind of, it can rack your brain a little bit. So it's, so what we're going to do now is we're actually going to create more points by doing just what we did with that line where we have a flat list of coordinates. We're now going to actually make that into a grafted Y dimension. So now that's going to grid this out and make our branching even more complex. Now we have 7 lists of 7 items, and all of a sudden our attribute tree does not match our object's data tree. So it's telling you your branches aren't lining up. So to fix that, I'm going to make a little more room here. To fix that, we're going to use the longest list component, which is going to kind of match list A. So it's taking a list of 1 items. Actually, we don't want that. Let's not graph that quite yet. And then we're going to put in our flat list of numbers. So now we can kind of create, if we go into here, grafted, we would have matching lists. We're going to take this a little further because we're going to add in some additional user keys. Actually, that'll be the next one. So so to recap that a little bit, we created a more complex data tree. Then we took our flat list over here and matched we take our longest list. So this has 7 items. That has 7 items. So that essentially is going to duplicate our data so that when we graphed, we have 49 branches that will go into our 49 geometries. So now that we're there, we're gonna create some additional. I'm gonna show you how to add in multiple user values. So currently we have our number, which is kind of not correct. That's just everything's a 1. So that's actually more of our column. So we want rows. And then we want a unique number for every one of them. That's gonna change when we dynamically change things. So we're gonna use our format. Once again, we're going to use the longest list, and we're going to start moving a little quicker here. So hopefully we can get through, because there's some fun stuff that we still only got about another hour. So we're going to make this a multi-line data. We're going to have number, column, and row. Once again, Elephant is helping us out, saying, hey, the number of keys needs to match the number of values. So we gotta do some data management here. So we're gonna take this one, graft it. And the reason I'm doing this so quick is because I've already kind of gone through this. So but even for myself, who's had a lot of experience with data trees, you got to sit here and kind of, hey, this is going to match up. What am I actually doing here? I can help myself out by naming some stuff. I think this is the column. This is the row. Graph. Here. And what we're looking to make, so what we have is 3 key value user keys. This could be parameters. So we need a list of 3 different items. So that's not what our current list. Now we even have 1. So we're going to use our merge component here, and then we're going to create our number, which is going to be our column, and this one, and we're going to format that into our number. Hopefully I got it right. So that's going to be data 1. So we want that to be our first D. Our second one is going to be the column. That should fill out there. And our row. So you'll quickly notice that our results aren't good because this was never grafted. So I'm going to graph that. And we're going to want to simplify all these branches so they match up, because right now they're not simplified, so they're not merging. So good example of the simplify component. Now we have 147 values. But the key point is our lists. So we can look at our tree statistics. So we have 49 branches, 3 items in each one. We don't want our user values grafted. Now everything is right. We have 49 attributes because we matched up our list of 3 user keys against each individual value, and that can match up with our 49 data trees. And once again, we can see it reconstructing. So now when we go here, we're on column 1, row 7, number 7-1. think we want those. Yeah, that worked. So now we have individual numbers plus rows. Excuse me for the a little bit of mess here, but we're starting to have to do things a little quicker. So. Not sure. Yeah, that's a tough one to keep up with. So once again, that's getting to this part right here, which is 3.3 Rhino branch data. We'll go a few more minutes and we'll take a quick break before we get to the taking this branch data into Revit and doing some more Revit type stuff. I think I'm just gonna go ahead and open up data filter. Hold up on that. So what, like I said, I'll cover this really quick. What this gives us the ability to do is when we reference by bake name, maintaining the structure. Now we have access to our rows right here, or we can query Rhino. So we have our attributes or our reference. So we can reference by user attributes, and then our filter. So we can filter by layer name user attributes. But here we're grabbing just row 1, and then we're grabbing one item out of here. So in our next phase, we're going to show how we can duplicate this whole data structure in the Rhino or in a Revit using Rhino inside Revit, and at the same time be able to find one single piece of geometry that corresponds to both Rhino and Revit. So if we made it through that, that's probably one of the tougher parts. So.
But you can start to see that the workflows that we see, the most useful workflows we see more often are the ones that have, there's certain data captured in the Rhino model, and that would be, again, this facade looking thing, and then somebody wants to recreate those elements in Revit, but they want that data to carry over, the data that's on the Rhino model into the Revit model. So when it populates the Revit families, there's corresponding things. So there's corresponding, that data shows up over in Revit. So by far, this is by far the most advanced thing.
Yep. Yeah. So when we're referencing by bake name here, so I can put in a value list and quickly filter by these properties. I turn the preview on. So quickly navigating your data, either to use it again in Rhino, use it in Grasshopper, or use it in Revit, or one of the other Rhino inside products, is Rhino inside Tekla. These all work off these same data structures, and they're, like I said, the Elephant plugin is my preferred one, but there's Human, there's others. Rhino 8 is going to have these data accessibility, block accessibility, native in Grasshopper 1. So a little less plugins with a lot more communication in between whichever programs you're using Rhino Inside for.
So Jeffrey, do we want to take questions now about workflows and things? And
I was thinking like a 2-minute break or a couple-minute
Okay.
break. Maybe you can answer a question or two.
Okay.
And then I'll go into kind of the fun stuff. We're gonna put that branch data flow in the Revit. We're actually gonna, and then we'll modify some parameters. Like I said, we're kind of running out of time, so we'll try to go through those, have an overview. Probably we'll try to keep it at around 20 minutes or so it'll be pretty good, and people can at least know how to play with those on their own time, and then we'll take some questions. So
Okay.
Couple-minute break.
Okay.
Okay, I'll be right back.
All right. So anybody got any questions in this mess as it might be?
This isn't related to workflow, but is there a plugin that allows you to see the component name above the actual component?
In Grasshopper?
In Grasshopper, yeah.
Yeah, that's
Where it says
spectacles. That's
spectacles.
spectacles. I think if you go into the package manager, you can get it. So if you're in Rhino and you go to type in package manager, I think you can type in spectacles, and that's what does that for you there.
Oh, sunglasses.
Sunglasses, sorry, sunglasses, right? Sunglasses, right?
Yep, and I included that in the support files. Once you add it to your Grasshopper folder, right here, you're going to have to restart your Rhino. So that means closing out of Revit, restarting Rhino to be able to get that to show up.
Got it. Thank you.
Yep. Yeah, it's a really nice, especially if you're sharing definitions. And I personally like working without the full names on. So having a set like that kind of keep things more compact.
All right, another question though.
All right, what do we got? Yep.
Yep, the Control Alt click the on the chat. Anybody wants that? That is a super good recommendation, which is use your Control Alt click to show where component comes from. So.
All right, so I'm gonna go to 4.1. Kind of just walk through this. So I get some extra stuff. A lot of this is going to look familiar. I changed, and so we kind of created that box structure, but realistically, you could just use a native Rhino grid component, either rectangular or square. I've kind of set it up to follow the resolution of this image. So it's pretty much the same thing, but the same data structure that we just went through to create our properties. So in this one, we have our grid, which is controlled by this slider. Oops. Keep it at 18. We have our box rectangle, which we're orienting to the grid. And then we're feeding the center line, the center point into the image sampler. So the image sampler should find that So that's a 20 almost square image. And then we're going to, that outputs the color where those points are hitting in relation to the image. So that's where we're keeping the ratios the same. So it's taking these points, sampling the image to output the colors, which we're going to kind of the same thing we did in the beginning where we converted that to the material. So I'm turning on. We're going to add our direct shape. We're going to define our number, row, and column parameters. Add those to the document and modify. So this is just a direct shape. So if I go over to our here, so you can see it got our number, our column, and our row, and applied that material color from the shader to the material. So we're able to take our list of 144 objects of 12 trees with 12 items to the same corresponding list of materials. And it's not the best looking smiley face. A little low res. So I'm gonna actually double click on here because I know it takes a little bit. And we'll put that at 8. And give this a moment. Now we have a more dense product. We could probably do that. Well, we'll move quickly. We're running out of time. You can quickly see how I mean, we still have our properties are now our number of our item 28, 28, 28. Row and columns. So we're maintaining our data flow of our structured data of Rhino user text and changing that into the element parameters. We're also using the color generated and keeping that maintained with its corresponding geometry. So the next one we're going to do, I'm actually going to create a new file here. I'm going to delete these and then I'm going to open up. See. There was a Rhino example file. So this has got a family in it. So I have nothing on my Grasshopper. Oh, we're going to do the same sort of thing, but we have a family, a generic model family placement work plane that has some parameters. So some instant parameters that we could change manually right here. So I'm going to open up this definition with the solver locked. I don't remember the state I left it in. So locking the solver, you can kind of open up your definition, see what's going on before it gets pushed into Revit. So now we're doing Rhino Revit family parameters. So that's our same definition from before. But this time we're querying our family types for that family. We're adding the location per that center point on the grid. And then we're inspecting the element to get its parameters. So box depth, box height, box width, setting those parameters, as well as a shared material parameter that's on the family. So I go back here. And I got too much stuff. You could see here there's a box material as well. So these are not direct shapes, these are families. And then we're gonna fill in the thing. So let's see. Our resolution's 18, so that'll go quick. So let's go ahead and unlock the solver and let it do its thing. So we're not, oh yeah, we are in share. So once again, we have our low resolution smiley face. This time, everything is actual families with parameters with a display material. And we're still getting our numbers. We're on the third row, first column. And then once again, we can do change the resolution. We'll put a 6 this time. Give it a minute. This one's taking a moment. That one. So, gonna do a high resolution smiley face. Is there any questions? There we go. So there we placed, I don't know how many, 1,369 families. Changing their instance material for that location.
One of the things to remember about this is, like one of the things Grasshopper can do is generate a lot of objects, which people have commented on already. And when you're pushing that into Revit, that can take a long time, obviously. But remember that it may take a couple minutes, or it may take 5 minutes sometimes, or something like that. But remember, it's a whole lot easier than doing it by hand in Revit. So it's still a lot faster doing it than doing it that way. So
yeah, and like I said, the goal here is these workflows are going to apply to all sort, like anything that you're going to be doing in Rhino inside Revit. You're going to have control your trees. You're going to have to be able to get the parameters, set parameters. Yeah, let's see, got one more. No, not there.
I have a question. If you have a object in Rhino baked with LA front, and you've got 15, 20 parameters, different data points for that object, what's the most efficient way to transcribe that whole data set into the Revit instance? Because it looks like if I'm understanding correctly, you're using that defined parameter like once per data point.
Yeah, but you can put as many as you want on there. So you could give it a list of parameters. It depends. The question, it depends. So like if it's just text information, like let's say it's actually is the index, so you're saving on it the column and the row, that cell on the facade because you want to use it, or you're going to use it later in terms of a schedule or something like that. Then you would, you could decide to have multiple, Elefront will take a list of parameter or create parameters, can create multiple parameter names on the object in Revit, as many as you want, and you can store whatever data you want in there. So, or any strings you want in there. And so that's pretty straightforward. Where it gets a little more complicated is when you have intelligent Revit families on the other side, and they have parameters like height and width and I don't know, thickness and shading amount and all these other parameters that maybe you set up on the Revit side. And you can populate those too just as well with Grasshopper. But that, that demands a little bit, the family has to be a little more sophisticated to take all that. Is that what you were asking?
Yeah.
Yeah, so in this example, we're taking the key value pair. So there's number, row, and column, adding that parameter, setting that parameter. Same thing we did in
But are we creating one parameter or creating three?
Three.
Yeah, we're creating three parameters there. Yeah.
Yeah.
So yeah, you just hang over define parameter for a second. Just slow down here. Can I go scroll in there close? That's okay.
No.
So see, we've created three parameters there because we gave it a list. Right. So we're giving it a number, row, and column parameter. So each one of those direct shapes is the direct shapes we're throwing them on our families, but we're going to have three parameters on there, each with a value in it. Does that help?
And then here's oh, go ahead.
No, that clarifies it for me. I was maybe missing a node there in that pipeline.
Oh yeah. And then the branching and listing and all that stuff makes a difference. So you got to watch for that too.
So here's an example of we created a filter, a Revit filter that's parameter filter. So we're querying the Revit project for this parameter and then getting all the box, creating a filter that just gets the elements so that, and then the exact same thing's happening with the reference geometry in Rhino. So if we switch it from column, so whatever column we want, and then we're using the select element here, we're grabbing that same row in our Revit. So the data, and like the way we structured this is if we change our resolution, all this workflow is going to actually maintain those relationships. So you can see immediately, either if you're working in Revit primarily and then sending to maybe Rhino for fabrication purposes, or the opposite, you're working in Rhino and sending to Revit, you can maintain your data in a complex way. You could, we're using three data points here, but you can quickly you can add more and use Elefront or one of these attribute querying components to filter, manage, check your data in either project.
And I kind of mentioned this early in this workshop, but this is the kind of data, the kind of workflows we're starting to see more and more of, where people are storing more and more and more data on the objects in Revit, or I'm sorry, in Rhino, right? So more user text, more information. Sometimes they're storing all the data that they use to create the object in Grasshopper. They actually store it on the Rhino object. And then when they move it to Revit, they can move all that data over so that if they ever need to reference it and get it back, they can get it all back. So it becomes this workflow of data that is that's kind of, I would have to say, in this last year or so has been the emerging trend that we've seen more and more of. And that's actually one of the reasons this workshop has gone so heavy toward data, is because it's the one thing that we're seeing more and more of when using Revit. And it is a more sophisticated way of working the two together, but it takes some getting used to, and especially for somebody, for instance, that's used to using Grasshopper and Rhino to solve a lot of problems. Usually we're not so worried about data because it's essentially encoded in the Grasshopper definition, but Revit needs it in text.
And people, I mean, when you hear data driven, right, especially in the design community, you're thinking of like sunlight analysis or weather analysis or structural analysis, or something where you're using large data sets to inform the design. But this is more of that's big data, where this is kind of little data, where we're using very particular parts to be data driven, but it's not driving the design, it's driving your workflow and organizing and managing your workflow in a data driven
And it's
way.
data that's going to inform schedules later, or like fabrication. So Jaffe's got a ton of experience with fabrication, and a lot of this information is going to be used to inform the fabricator later. You know, a good example is the row and column and position of each one of those panels.
Yeah, anytime these could be flipped up. Let's see.
Any other questions?
Yeah, so I saw, let me see. I think it was Libney had some questions about legends. Because legends are a big thing. I was helping a user the other day with this workflow, and he said I could actually share it publicly. This will take me a minute to. What is that? Fired up the Revit 2023, but I'll show this Legends option that uses Rhino inside Revit. Was there any questions from before that we need to start addressing? Did you make a list, Scott?
No, I'll be kind of answering as we go along.
Oh, okay.
Can you guys hear me?
Yep.
How about we were talking about this week about these objects. When we send these objects to Revit, how does it work in terms of collaboration with the other colleagues that are also working in these Revit files? Can they sort of like, for example, what happens if they unpin these objects?
Okay, so yeah, let me answer that because that's a good one. So if you, for those of you that don't know Revit, so if in Revit objects can be pinned, and once they're pinned, you can't, it's essentially like locking them, right? So somebody in Revit doesn't want somebody else to mess with the object, they'll pin it. And so in Grasshopper, pinning means when something's pinned, it means Grasshopper is in charge of the object and Revit's not. So if somebody in Revit wants to edit it outside of Grasshopper, then they would unpin those objects and that would release that object from Grasshopper. And now they can edit it with Revit. Okay. So unpinning them would release it. Now here's the deal. If it stays unpinned, Grasshopper never can get control back. So which is fine. If you repinned it later, you could just say, oh, somebody unpinned this, I need to repin it. But then again, remember that if somebody pins it again, Grasshopper is now in control, and it's going to overwrite any of the changes that somebody made while it was unpinned. Does that make sense? So that's
So-
what pinning.
Yep, so there's we have the tracking mode. So one of the things that allows us to keep things live. So here's a wall, and if I change something here, like a comment, red, where do if we change the length of the wall, of our pinned wall, you'll see that it maintains our property red. If we switch our tracking mode to replace, that is going to destroy that old wall and give it a new element passport. It's going to give it it's going to be a new element versus and get rid of that red value. The third one is disabled, which instead of replacing this wall, it would actually start creating walls for every different value. You can unpin this, move it, but as soon as you pin it back and then run it, it's going to go back to being controlled by this component. Does that help?
One of the
Yeah, good stuff.
Yeah, one of the discussions that always comes up is can I sync Rhino and Revit together? And like I update one and the other one updates and vice versa and all that stuff. And the answer is no. So, and the reason you can't is you run into a logic problem of who's in control and who's, just kind of following along. And so Rhino inside Revit, you can go from Rhino to Revit, or you can go from Revit to Rhino. You're just not going to go both ways at the same time on the same object. And so that's, you kind of have to, when you're establishing workflows, you kind of have to establish which one is the source of truth at any one point, and which one is the, and where's the data stored. Those are the two, which one's the source of truth and where's the data stored, and they don't have to necessarily be in the same place. But and it may change, like early in the process, like the floors might be in Rhino for a while, and then the floors have been set, so now they're in Revit. The Revit source of truth are the floors. But later in the process, the facade maybe is still getting designed. And so the source of truth continues to be Rhino, even though the facade's showing up in Revit. The source of truth is Rhino. And then at some point, okay, now the facade's set, we're going to put it into Revit, and then off everybody goes with Revit, and you kind of leave Rhino behind. So I would think about it less like how can we sync the two, and more by which one's the source of truth, right? Where are we storing the data? Which one's the source of truth? And then, therefore, do we need to bring the floors over to Rhino so we can model? Or do we need to take the floors from Rhino into Revit so we can model, if that makes sense? And so that kind of balance between the two products is the real key here.
So this
You're
is
still, yeah.
okay, go ahead.
No, go ahead. It's good.
So this is the problem that was brought to me the other day. This is a 3D model of plumbing. And the user, I've never used these components much. And they wanted a workflow with a piping system. So the piping system has a type where you can actually do a graphics override in the piping system with a different color. And the user wanted to make a legend. So like this, so that corresponds with the color. So the legends are really difficult. So instead of using the legend component, this is actually a schedule. So what this requires is, and I think it was 2022, you can have a type image in the type, so that can be scheduled. So it's an alternative way of doing legends, because these schedules, these can be per sheet. So it's if this is these types of connections are showing up on the sheet, it's going to fill out the legend. So to do that, what we did in Rhino inside Grasshopper was, and it got a little more complicated than I wanted to, because let's see. Yeah, so what I ended up doing is using Rhino inside Revit to get the material from that piping system. And then I took was able to get a filled region, duplicate the filled region, apply that color to the parameter of the filled region, create a new drafting view of said region, and then override the properties. So what that did for me in the drafting view right here, so it generated this drafting view with just this box in it. And then I used export view image to take an image of each one of these, and then a small Python script that applied it to the image option for each system type. So the end result, so that saved out an image for each one of the types, then added it to the piping system type, which then could be scheduled into a schedule, which can go on multiple sheets. So now that's kind of a new way to do a legend. So this image could be actually any, not just a piping system. This could be your wall schedule. This could be your door. Like, there's a lot of things you could do. But it's a more a super practical way of using that kind of the same workflow we were just doing. We're getting a list of items, or where's my items? I guess it's over here. But so hopefully that will give you some ideas for, instead of using the old legend component, to actually make schedules with type images.
This is really good, Jaffe. So correct me if I'm wrong. The schedule, it's sort of, in a sense, reading what types of pipes are being used in the main drawing, and then it only shows those that are.
It's a setting.
Showing, yeah, you're right. It's showing
Filter by sheet. So if you put it on if you're filtering by sheet, he's got some other stuff going on, but yeah, it's say filter by sheet, and then whatever sheet you place it on, it's gonna just grab the ones on that sheet.
Yeah.
and then the image is stored in the type parameter.
Yeah, and the image was generated off the material, actually there's the material overrides. That's where it got a little atypical, because these graphics overrides aren't in any other Revit type that I know of. Usually those are in a view, but for some reason so that was a little different, where I had to kind of jump into some Python and get it in there. And it was the same thing here, where applied actually did a graphics override by element to give to put the pattern lines and everything in a different color. And that actually worked out really well. So hopefully we'll get a graphics override component. So we can use these either by category, by filter, or by element. But these are the kind of workflows that, if you bring them either by emailing me or posting the questions of the forum, that's how we're gonna add more components. That's we're gonna doesn't matter how silly you might think it is, you can email me and we can kind of work through the workflow and see what's possible, because a lot is possible.
No, thanks. Really, really good stuff.
All right. So are we ready for more questions, or are you going to do more?
No, I'm ready. I just
Okay.
wanted that was the answer to the legends one.
All right. So here's the question. All right. So now you've seen all this, you've talked about. So what workflows are people thinking about to maybe even don't even know if it's possible, but to try this on? Like what, I guess a bit more, maybe a better question is, what workflow problems do you think you have that you're wondering whether this could help with?
I have an upcoming problem in Revit that I've been trying to solve with Rhino Inside for a while, which is legends. I know how to do it for loadable families like Windows, whatever. That's not a problem, because basically what I do is I don't treat it as a legend component. I just simply get the geometry, I manipulate it in Grasshopper, and from there I can create the legend very easily in Revit. But I have a lot of issues with legends for system families, walls, and whatever, like getting that kind of section of the wall. Would there be a way of doing that?
Well, and yeah, I mean, that's where that last kind of, did I close that out? Oh, not that one.
Are you trying to get the layers of the walls, or are you?
Yeah, I mean, if I can get the legend component, I don't have to care about the layers. But if there is no way of getting the legend component, then I really need the layers.
Yeah, because you're using legend. So one of the things about the legend component is that as soon as you make those legends and you go to purge your file, all those components don't get purged, even if they're not used. But I mean, there are some benefits to legends. I don't have a good solution for that, and that's kind of where we went. Alternative solution is to make this a schedule with a type image, and that type image could be of a wall section or a wall plan. Or I mean, there's definitely a lot of possibilities that I haven't even fully thought about. But
yeah, but at the end, I will also need to replicate the filling of the layers, because I could even design the block by myself in Grasshopper. But then I would need a filling. Like if they are using some sort of insulation, and sometimes it's like the continuous infinite loop, but sometimes they use the triangles, sometimes they use something else. So I was wondering, that's
Yeah,
why I asked.
well, and one of the difficulties in supporting this is that when people have questions, it's kind of it's hard because that's a particular file with a particular problem with a particular version of Revit with a so if you need to upload a file privately, like if you go to Rhino support, the Rhino support has a ability to upload a file privately, or we can I mean, if you have all your stuff together, we can get on a quick call. You can look at it. I can get the files. I can kind of toss it around a little bit and try to come up with a workflow.
Yeah, that would be great.
Yeah. I mean, granted, it's like when you start getting deep, Revit API is massive. It's a battleship. It's an aircraft carrier, and it's nobody really knows it completely. And I'm learning every day. So bringing questions so I can learn, or the community can learn, is the way this is going to really move forward. So yeah, but like in that case, it'd be nice to see the files, kind of see the process, what you're trying to do, and then and kind of work through it.
Got their workflows?
There was oh, here's one. So one thing about, I think there was a question about BIM 360 and other documents. So we can get our Revit links. So in our document tab, you can get open documents, active documents, and then when we're querying things from different documents, query elements, if I'm going to make, not that one, if I'm going to make a query on a different project or a link. So if I go to category filter, then I'm gonna query categories, and I'm gonna get my walls right here. It's gonna bring in the walls of the current file, which is the link model and the document model. So there's a structural link here, and we're only getting the ones that are from the other file. So this is where, if there was a BIM 360 or you had, this is where you're able to kind of specify the document. So now we're getting the linked model elements.
Yeah, jump onto the website there, Jeffy.
There you go. The website.
Yep. So you can, there's resources about this. So if you go into Rhino.inside.Revit, okay, and then go down, scroll down here. No, yeah, and go down to documents and links. It's up a ways, right above 360. Yep. Okay. And you scroll down. You scroll down about halfway here, a little bit more maybe. Keep scrolling down. I mean, you can go to linked elements on the side there, but keep going. Keep going.
Yeah.
Go up a little bit. Okay, so here's our linked elements. So if you go up a little more, there's actually a video about all this. So how to select, how to work with linked documents, how to feed them into a different document. This video and these things, and like, for instance, you have to worry about the location of the linked object because it's actually technically in a different position in the linked model than it is in the current model. And there's a way to do that. And so that's what this is. So that's one thing I wanted to mention. And so you can look on this document right here for that. Then right below this on the left, you see it says BIM 360 Cloud. The other thing to understand is that companies have been asking us, can I store my Rhino 3DM files and my Grasshopper files alongside my Revit project files in BIM 360? And the answer is yes. And so we have a plugin that you can get from the package manager. It's free. And that will allow Rhino and Grasshopper files to participate with BIM 360. That means you get the same backup, the same revision control, and the locking against other people that have it open so that you don't have more than one person writing to it at the same time, just like you would with a Revit file, but with Grasshopper and Rhino files. Okay, so that's available too right there on that part of the document too, if that's helpful.
Yeah, that's a big one because that does get a little tricky, especially if you're using the coordinate systems. Rhino is always going to be 0,0. Your geometry, everything's going to work a lot better the closer it is to 0,0. You'll get Revit projects where the file is miles away, and that's going to be an issue, even in just translating geometry because of the floating point aspect. So this is a good rundown on it.
Yep. Good. Any other questions about any other workflows you're struggling with or thinking about?
I don't have a question about the workflow, but I don't know if it's relevant because they asked me this week, are there any plans for you to start developing Rhino Inside for other programs? Like, I mean, now you did it for Revit. Are you planning to do it like for Civil 3D or things like that?
One of the strong ones is Rhino Inside Tekla, which is incredible program. But that's developed purely by Tekla. So we have all the framework there. I mean, McNeil is supporting Rhino Inside Revit. They're going to continue to support it. There's going to be a 2.0 coming out with element tracking in the SDK, curtain grids, all that stuff eventually. But the onus is on others to kind of develop if they want to. We're here to help.
But yeah, so far
looked at it. Okay, go ahead, Scott.
Yeah, so far we haven't done I mean, there's a bunch out there, but Civil 3D is not one that we've got a lot of requests for. Is that where, I mean, that's an area that your company would be interesting about?
Maybe, but I will need to double check. Yes.
Yeah. I mean, one of the things to remember, I mean, this is, I mean, it's hard. It's not hard. It's just, there's a lot of work that goes into how close these work together. And, it takes a really deep understanding of both products and the workflow that you want to automate. That's where the Tekla Live Link and the Tekla Inside has been really good because they, of course, understand where Rhino and Grasshopper can be useful to their clients. But
and we can see right here that the wires are dashed, so that means there's multiple branches. They're going against solid wires here, so they're creating these complex data structures in the Rhino Inside Tekla, which is, that's why wanted to focus on that aspect because that's pretty generalized for whatever workflow you're doing in Rhino in Grasshopper or Rhino inside Revit or Rhino inside whatever. So
I did I'm sorry.
Go ahead.
I did a workflow implementing Tekla and then the live link to bring like a live update from Tekla to Rhino and Revit. I was trying to implement it for a project, but once it got to, I don't know, over 500 members, it got very buggy. But I had, it was actually working. It's just, it probably needs a little more work for the Tekla side, but
well,
so
yeah.
far so good.
You might have to slow it down too, you know, like, because they're using I mean, it would be interesting to see if, because of timing issues, if you were both in Rhino and Tekla at the same time, you may have timing issues. And so you might find you actually want to slow it down a little bit so everything can generate what it needs to generate in time.
And one of the things, I don't know if you noticed that, like what we were doing in our workflow there was we created the Rhino geometry, then we referenced it, and then we put it in. So actually all those steps could be in separate files. So you could kind of keep your definitions kind of slow. Like you're saying, you got a big 500 member thing. Like if you could separate that out, put the information into Rhino, have it in Rhino, and then only pull what you need when you need it, is going to give you so I try to stay away from those massive, long, strung out things that do 100 different things all in one magical Grasshopper script. Where if you're using the data, data-driven, kind of like we did, you can create more targeted workflows that are small scripts that could be shared. They're going to be robust because granted, your internal standards are going to, people are going to have to know the name of the attributes or have some inkling of what's going on or be able to maintain it. But you can create small, robust scripts that are going to not be a bear for new people to get into or try to remember what you did when you get back into it with some of those massive, long-winded scripts.
Yeah, that makes sense. Do you guys have anything on the realms of SAP or SAP 2000? That's something that we use.
Yeah, we don't, but that link exists.
Yeah.
You know, and so you've got your SAP 2000 plugins for Grasshopper, and those will run in Revit now. And so you can exchange that kind of data. And it's really interesting using Rhino inside to get all the analytic geometry out of it and get that all massaged. There's actually a number of examples of that on the website too. But yeah, SAP and GSA and there's actually Sophistic has a really good connection to Grasshopper, and all of those would run in Rhino inside Revit.
Yeah. So when we're referencing here by bake name, so this could be a totally new script here. And this will actually work on work session files too. So you could have different Rhino files linked into a work session into a project that would then you could query using the Grasshopper and Elephant, do something. And that's actually how their workflow goes. They'll have a bunch of small different Rhino files, Grasshopper files that all chain together to make robust workflows that while they're changing a facade or whatever through the program, it's going to maintain a nice stable workflow. Got a big thanks to Elephant and all the plugin developers and everybody that's contributed to the forum, because they do come up with some amazing stuff. I didn't come up with any of this. I just learned how to use it.
So we're running out of time here. So I did want to say though that we have Pedro Cortez is somebody that's coming over to the hackathon, so he'll be in person at the symposium and the hackathon. And Pedro, he works for us. He knows Rhino.inside.Revit, and he knows how to work with the Revit API a little bit. So anybody needs help with the hackathon and things like that, you can talk to Pedro. He didn't get a chance to be here today because he's actually traveling to New York today. So know that you have people, or you can go find Pedro and talk to him during the symposium or during the hackathon, and he can help with Rhino.inside.Revit issues. So. Any other questions before we close this up?
All right. Thank you very much. Feel free to reach out to me on the forum, email, message, anything, any question.
Thank you a lot, guys.
Bye.
Thank you, guys.
Thank you very much. This is great.